All right. All right. Hey, everyone.
Hello.
Welcome to our Rust 151 patch review.
Yeah.
I believe this is the third one we're doing, second one?
Third one we're doing together.
Right.
Third video we're doing together.
Third
Second
video.
release notes we're doing together. Yeah.
Cool. Oh, guess it's been
Exciting.
three. Yeah. So, for today, the plan is as usual. We'll be reading through the patch notes. For the first, I think I cheated a little bit. I read through it a little bit.
How dare you?
But yeah, we'll be reading through the patch notes for the first time and sort of commenting on it, providing some behind the scenes. Maybe, yeah, just give our thoughts. Like, subscribe. All right. You want to kick it off?
Sure. Yeah. So I thought you wanted to do the intro.
Oh, well, that was the intro.
Oh, you want to? Oh, okay. Right. So the first thing on the release notes is the Const generics. Yosh and I did a video about Const generics a couple of weeks ago. If you want a more detailed thing than these release notes, you can watch that video. But right now, Const generics MVP. Before this release, Rust allowed you to have your types be parameterized over lifetimes or types. For example, if we wanted to have a struct that is generic over the element type of an array, we'd write the following. Kind of looks like this. We've probably all of us have done that at some point, perhaps.
Yeah, so it's just an array of a type with a length.
That we have to provide.
Yeah.
So if we then use fixed array U8, the compiler will make a monomorphic version of fixed array that looks like this. So it substitutes the type T to U8, and then the list is U8 of length 32. So this is a powerful feature that allows you to write reusable code with no runtime overhead. However, until this release, it hasn't been possible to easily be generic over the values of those types. This was most notable in arrays, which include their length in their type definitions, so T over N, which previously you could not be generic over. So now with 1.51, you can write code that is generic over the values of any integer, bool, char, I want to say char. Using struct or enum values is still unstable. This change now lets us have our own array struct that's generic over its type and its length. And so the example kind of looks like this. So you create a struct called an array that has a generic T, and you provide a const length that's usize. And this basically constitutes the const generic definition. And so when you describe the list, you can then pass in the generic parameter you defined above in the struct definition of array. So then now if we then used array U8 32, the compiler will make a monomorphic version of array that looks exactly like the one before. So array U8 32, and then the list just gets those values passed in. So Const generics adds an important new tool for library designers in creating new, powerful, compile time safe APIs. If you'd like to learn more about Const generics, you can also check out the Const generics MVP hits beta blog post for more information about the feature and its current restrictions. You can also look at our video, like I mentioned before I read this whole thing, that goes over that blog post.
If we can figure out how, we might add a little banner here, there, somewhere.
Right. If we figure out how. Do you want to talk about the array IntoIter?
Yeah, but before we move on, I want to quickly cover like one small thing here. The word monomorphic. I don't know. Do you know what it means?
I actually don't know what it means. They're using fancy words, but given the example, I guess what it means is that it's const at compile time version of array, but perhaps I'm wrong. I could be wrong.
It refers to you'll commonly see it. I figured it's like a little piece of terminology that's not being explained in the post. But monomorphizing is an optimization that a compiler does, where it will convert from very literally, here you say struct array T, and you can use it with any type T, or you can constrain it with like traits. And at compile time, the compiler will see like every single variation of every single like concrete struct that is being passed into this thing. It will code gen new functions that take that like thing.
Yeah, that's what I assumed by example, but I can never describe what I assume. But cool.
So important to realize is that monomorphization, and it is also called static dispatch, because it's like inlined and like create separate instances from, which is separate from dynamic dispatch, which is when you have trait objects and all the other stuff, and then you have a lookup in a V table at runtime. So rather than like figuring it out at compile time, you can do it at runtime. There's benefits and all this stuff, but monomorphization is for doing static dispatch at compile time.
Cool.
Little factoid, probably useful too. If you're new to Rust, useful to be aware of.
Or if you're bad with words, also to be aware of.
You're not bad with words. All right. Array IntoIter stabilization. I believe this is one where we were like, we hope this will happen like 2 patch notes ago.
Yeah. I wonder if they watched our video and they just made it happen.
Maybe they too are subscribers, at least in their hearts. Definitely not. But yeah. All right. So as part of Const generic stabilizing, we're also stabilizing a new API that uses it. Array IntoIter. Oh, maybe it's not. IntoIter allows you to create a by-value iterator over any array. Previously, there wasn't a convenient way to iterate over own values of an array, only references to them. So here we see, previously you had to do item array iter copied.
Right.
And now you can do item in, this call is like really fancy, huh?
Oh, that's very verbose, eh?
Yeah. So this is what we were like showing earlier as being like, this is what you have to do now. They didn't do the optimization yet that we were like wondering about.
Right.
So it's different.
It's a bit different.
So ideally you could just have the array for item in array would just work. But that might be a breaking change that needs to be considered. So for now, it's just this. I believe what did land is our suggestion at the end of the Const generics MVP video, where we opened up a bug.
That wasn't the Const generics MVP. It was the previous release notes.
What?
Yeah, because it had a different optimization for iteration over arrays. There was a different optimizations to iteration over arrays. It's a very complicated sentence. I think it was then, yeah.
The good thing of having this recorded is that we can go back and figure it out.
Yeah.
I'm somewhat confident it was the other one though, because this is like they specifically asked for feedback in terms of like what's it, diagnostics. Do you have any diagnostics issues?
Maybe.
So
no, it's been so long.
So I believe what will happen now is if you do for item in array. Oh, hey. For item in array, we will. Sorry, I lost my train of thought there. I had to click something away. If you do for item in array, it will suggest you use IntoIter instead, rather than like throwing you a curveball. Yeah. So yeah, just finish this out. Note that this is added as a separate method instead of IntoIter on arrays, as that currently introduces some amount of breakage. Right. Currently, IntoIter refers to the slice by reference iterator. We're exploring ways to make this more ergonomic in the future. Right. Amazing.
Makes sense.
All right.
Cool. Cargo's new feature resolver. Ooh, that's interesting. I have not read about this. Dependency management is a hard problem. And one of the hardest parts of it is just picking what version of a dependency to use when it's dependent on by 2 different packages. This doesn't just include its version number, but also what features are or aren't enabled for the package. Cargo's default behavior is to merge features for a single package when it's referred to multiple times in the dependency graph. So for example, let's say you had a dependency called foo with features A and B, which was being used by packages bar and baz. This needs a diagram. But bar depends on foo and A. Foo
Oh my god.
and baz depends on foo plus B. Okay, I think I have it. Cargo will merge both of these features and compile foo as foo plus AB. This has a benefit that you only have to compile foo once, and then it can be reused for both bar and baz. Right. So this also comes with a downside. What if a feature enabled in a build dependency is not compatible with the target you're building for? Yeah, that makes sense. A common example of this in the ecosystem is the optional stud feature included in many no-stud crates. That allows crates to provide added functionality when stud is available. So imagine you want to use the no-stud version of foo in your no-stud binary and use the foo at build time in your build RS.
Are you still following it?
Yes.
Okay, great.
Actually, surprisingly, yes.
Okay.
This needs a diagram, actually.
I was going to ask, do you want to build the diagram as we go? Let's not.
Oh, yeah, I'm not hooked up with my iPad.
That's what you meant. Yeah, sorry.
If your build time dependency depends on foo plus stud, your binary now also depends on foo plus stud, which means it will no longer compile because stud is not available for your target platform. If your build time dependency depends on foo plus stud, your binary now depends on foo plus stud, which means it will no longer compile because stud is not available at the target platform. Yeah, that makes sense because you build both.
I really wish they would not have used foo and bar.
Yeah, that's definitely could be something else.
I think if we would call like foo surdy or something, which is a very common like feature flag for people to add, maybe it'd make like a little bit more sense.
Yeah. Okay, so this has been a long-standing issue in Cargo, and with this release, there is a new resolver option in your cargo.toml, where you can set resolver 2 to tell Cargo to try a new approach to resolving features. You can check out RFC 2957 for a detailed description of the behavior, which can be summarized as follows. Okay, I want to see the summary first, and then we can look at this feature. So dev dependencies, when a package is shared as a normal dependency and a dev dependency, the dev dependency features are only enabled if the current build is including dev dependencies. That makes sense. When a package is shared as a normal dependency and a build dependency or proc macro, the features for the normal dependency are kept independent of the build dependency or proc macro. So you have two different builds with different features.
To me, that was the word dependency 5 times in one sentence. Sorry.
Yeah.
Independent of the build dependency for the normal dependency of the... Oh my god.
I'm glad I said that properly and did not stutter.
I don't think I follow what that meant. Can you maybe explain it to me?
So I think what it means is that when you do have several different ways a package is used in a build dependency and a normal dependency, you build two different versions of the package with appropriate features.
Okay.
So then the features enabled specifically for normal dependency are built for normal dependency, and then when you're building a build dependency, you enable different features and you build a separate package or a separate package.
Okay. So say we have like 3. Okay, so we have 3. We have a crate, just to verify. I'm trying to think of the right words. So we have a mono repo, right?
Yeah.
A cargo workspace, and we have like 3 crates. Cool project macros, which is our proc macros. Cool project. And cool project also has like build dependencies because it has like C bindings or something.
Yeah.
And they all depend on sturdy.
Yeah.
Or something.
Yeah.
Then whatever flags we give too sturdy, or maybe some HTTP library, it doesn't matter, right? The macro can use different flags than the build step, which can pass different flags than our cool project, which can use different flags on that HTTP library.
Yeah, that seems about right.
Okay, then I follow what that means.
And I think that means you will have different build packages for all of those.
Oh my god, I'm just realizing that like these things are like one sentence, and like the word dependency is just
50% of the sentence.
Yeah, pretty much. All right, but okay. Follow. Thank you.
So target dependencies: when a package appears multiple times in the build graph and one of those instances is a target specific dependency, then the features of the target specific dependencies are only enabled if the target is currently being built. I think that's wonderful. I like that a lot. So I think if you're building stuff, like if you have a target specific dependency for WASM and non-WASM, and your non-WASM dependency is depending on libc stuff that is not going to compile to WASM, personal experience, I guess it will not compile at all or not be part of your dependency tree at all, which is great. I like that a lot.
Yeah.
While this can lead to some crates compiling more than once, this should provide a much more intuitive development experience when using features with cargo. If you'd like to know more, you can also read the feature resolver section of the cargo book for more information. And we'd like to thank the cargo team and everybody involved for their hard work in designing and implementing the new resolver. So I want to know if the feature resolver thing has been updated.
Yeah, you can just pass resolver equals 2.
Okay, so it documents all of this. I think I would actually really like to draw a diagram for this because I don't think it's very clear at all. Oh, they do have.
Hey, diagram.
No, that's feature unification.
That's what the resolver does.
Yeah, okay. My package, foobar, file API, handle API. And then so when API compiles with all those features.
Exactly. Should I move on?
Yeah.
Cool.
Splitting debug information. Take over.
Split. I'll start reading from there. All right. Splitting debug information. While not often highlighted in the release, the Rust teams are constantly working on improving Rust compile times, and this release marks one of the largest improvements in a long time for Rust on macOS. Cool. Debug information maps the binary code back to your source code so that the program can give you more information about what went wrong at runtime. In macOS, debug info was previously collected into a single .dsym, dynamic symbol folder, using a tool called dsym-util, dynamic symbol util, which can take some time and use up quite a bit of disk space. All right. Collecting all of the debug info into the directory helps in finding it at runtime, particularly if the binary is being moved. However, it does have the drawback that even when you make a small change to your program, dsym-util will need to run over the entire final binary to produce the final .dsym folder. Okay, so that makes sense. Mm-hmm. Even a small change changes the output, and they need to reparse the whole thing. All right. This can sometimes add a lot to the build time, especially for larger projects, because those have more debug info, as all dependencies always get recollected. But this has been a necessary step, as without it, Rust standard library didn't know how to load the debug info on macOS. Okay. So, improvements. Recently, Rust backtraces switched to using a different backend which supports loading debug info without needing to run dsym-util. And we've stabilized support for skipping the dsym-util run. Okay, nice. This can significantly speed up builds that include debug info and significantly reduce the amount of disk space used. That sounds like a win. We haven't run extensive benchmarks, but have seen a lot of reports of people's builds being a lot faster on macOS with this behavior. You can enable this new behavior by setting the -c split -debug info equals unpacked flag when running Rust C, or by setting split debug info profile option to unpacked in cargo. So the way you do this is you have a cargo toml file, you add a new key called profile, and under it you create a new key called split debug info equals unpacked. Oh, there we go.
You
Hey, I just pronounced this.
You probably want that in dev. Oh, yeah.
Here.
Yeah, I was like, you probably want that in dev. And then they've written it in dev already.
The unpacked option instructs rustc to leave the .o object files in the build output directory instead of deleting them, and skips the step of running dsym-util. Rust backtrace support is smart enough to know how to find these .o files. Tools such as LLDB also know how to do this. That's important. This should work as long as you don't need to move the binary to a different location while retaining the debug information. So for those of you who don't know what LLDB is LLVM's debugger, low-level debugger, I guess. Even though LLVM no longer stands for what it used to stand for, so it's just LL debugger. Yeah, and that just works. That's amazing. So
have you ever debugged anything with Rust with LLDB?
No.
Me neither.
I have run debugging from VS Code. Right. It just has a built-in like debug support, and you can just click breakpoint, run. It works.
Cool.
Yeah. So you need to opt into this behavior, it seems.
That seems like a much more straightforward way of doing it than setting the flag.
Oh yeah, totally. The question is, do you want this in production? Like for release builds, it seems they don't recommend it. And I also wonder if they'll at some point enable this by default. I don't think we saw it tracked as part of the Rust 2021.
No, this wasn't part of it.
So maybe this will be up for default, like being a default in Rust 2023. Possibly.
Maybe.
We'll see. All right.
We talk about this stabilized APIs. So in total, this release saw the stabilization of 18 new methods for various types like slice and peekable. One notable addition is stabilization of pointer adder-off and pointer adder-off mute, which allow you to create raw pointers to unaligned fields. Previously, this wasn't possible because Rust requires end and mute to be aligned and point to initialized data, and adder as const would then cause undefined behavior as end adder needs to be aligned. These two macros now let you safely create unaligned pointers. I'm not going to read this out. Sorry, folks.
Why not?
Okay.
Yeah, no.
So we're using standard pointer. We create a packed struct, which uses a U8 and a U16.
Do you know what a packed struct is?
No. What is a packed struct?
I'm not too sure either.
Should we Google?
Maybe.
Should we pull out?
I can quickly look it up on my phone, maybe.
Well, okay.
Packed struct.
And there's like this repr macro that I've never seen before.
So I can tell you what repr is.
What is repr?
In this case, repr says it stands for representation, and it's the memory representation, right? By default, Rust's memory representation of any struct is repr Rust.
Right.
But we don't write it out because that's the default. But options are repr C.
Yeah, so that works.
Align it like C memory is aligned. Repr packed, which I believe is a squished version. But I'm not too sure. So repr C means also that the ordering in which things are defined matters.
Okay.
I just don't quite know what the repr.
Okay. Well, it seems
Packed struct Rust.
that packed creates 2 points F1 and F2. And then we do pointer adder off of packed F2 to grab the raw F2 pointer. because npacked.f2 would create an unaligned reference. So that would be an undefined behavior. And so then you can do like an assert equal on unsafe point to read the unaligned raw pointer we just created. And that would be 2. Interesting. Interesting.
So I believe repr packed seems like it may not align fields.
Yeah, like this mentions the fact that you can just go and pack.f2 because that would be an unaligned reference, meaning it's originally unaligned. So you gotta grab the pointer adder off from the packed f2.
Okay, fascinating. Should we just run this through Playground real quick?
Yeah, maybe.
Okay.
Hold on, I'm hearing cat meows. I'm gonna check my shit.
Yeah, is she in the balcony somehow? All right.
She's a snooze.
Okay.
Cat's a snooze. She's probably...
Naughty, you sleep.
Naughty is also
Okay.
a snooze.
Oh, we have to be good parents.
I think that they're probably just meowing in their sleep. Hunting pigeons.
Oh, pigeon.
As one does.
As one does.
Our cats don't actually hunt birds. They're not allowed.
They certainly try though.
They're terrible at it.
Okay, so I am curious. Debug. What's the error we get here? What? Execution standard error. Did that work? No. npack.f2 equals 2.
So I'm confused.
What? And thus be undefined behavior. Wait, is this undefined behavior unstable? No, surely not. Surely not. So that's a strange example.
It is maybe the read.unaligned function creates an undefined behavior. So they're trying to but you right away know that it's weird.
Maybe this forces an aligned read still.
Debug, you mean? DBG?
No, just using ampersand here.
Oh, okay.
Will still like create a aligned pointer. So here's where my knowledge of like these things starts to break down a little bit. Because like, what does it mean when you no longer deal with unaligned structures?
I've never had to work with that, so I don't even know.
It's definitely like optimization land, where you're like trying to do very fine-grained memory stuff. And you're like, oh yeah, we're gonna do a packed struct, and then in the extra bits we might mess around with that, or something like that. I would imagine like this is the direction of stuff. Maybe, yeah, I don't know. I'd be fascinating if someone had like more information on this. Leave it in the comments below. Help us out.
Yeah.
It seems there was always like an unsafe call to do this, but now there's a safe call to do this. Fascinating. I have no idea. What version of stable is this?
1.51.
Interesting. Yeah, I don't know.
Let's look into all the other methods.
All right.
There's 18 of them, so we've done one.
Well, we're lucky because I made the first two.
Oh, amazing. Okay. Would you like to walk us
Those
through?
are mine. Yeah. So this, I just said like, oh my God, pointer stuff, unsafe stuff. I don't know about that. And like, I welcome you to.
And now you're going to talk about ARC. Oh, yeah.
Oh, yeah. So this is like some pretty hairy, or is hairy the right word? I don't know. This was somewhat gnarly to write and implement, but it's important. So ARC stands for, I always say atomic reference counter, but that's never right. Atomically reference counter. Okay, atomic reference counter. Can we reload this? Get back to the method?
Atomically reference counted.
Fine.
Just being a wise ass, I'm sorry.
A little bit. So a reference counter in Rust, the way it generally works is you initialize it, and there's one of it, exactly one of it. So the counter sets itself to 1, and then you share it, and then every time you clone it, the counter internally increments by 1, and every time a clone is dropped, it decrements the counter up until the very last one. And when that is dropped, it sets the counter to 0, and the memory that these things reference to is freed. This is useful when you have an arc of a mutex is a very common thing. But if you just want to have shared read access to a thing, you just want to hand out ownership.
Right.
That's when you use an arc. Sorry, I'm not doing too great of an explainer, but arc is when you like want to start messing around and like loosening the borrow checker rules, but instead doing some runtime logic.
Right.
But sometimes you don't want to share something internally. You just want to have a counter. Right? You just really want to rely on the behavior that you can increment the counter and decrement the counter, right? Because that's what arc is good for. Other APIs you might think could be good for this is atomic usize, for example. But atomic usize, so here's it gets a little bit annoying, and maybe too detailed, I'm not sure. But atomic usize does not implement clone. So in atomic usize...
So would you use atomic... Is this when you would use increment strong count and decrement strong count in atomic usize?
So instead of using atomic usize...
Instead of using atomic usize.
So the way you can like increment and decrement atomic usize easily is by wrapping it in an arc. But an arc is implemented in terms of atomic usize. So you're wrapping an atomic with an atomic. So it's better to just use an arc directly.
Right. Okay. Now I understand.
Yeah. It gets a bit finicky, but specifically, this allows us to mess with the reference counter directly, where if you're implementing your own smart pointers, your own vtable stuff, like you sometimes need to do for wakers, being able to manually increment and decrement is way better.
Cool.
Because people used to do it by doing a clone and then a mem forget. So we clone it, increment the counter.
And then mem forget.
So it never calls drop.
Oh, yeah.
Yeah. And that was like increment the counter. This is a great pattern. I was looking at it. I was like, no. We should really like consider improving this.
Interesting. That's a cool little new unsafe method. Yeah.
It's like,
sorry.
Just for reference, you shouldn't be using this most likely, but this pattern was being used, so
you were just very excited.
Okay. It took me like 5 tries to like implement this patch.
Really?
Because I kept messing up the increment and decrement logic.
Well, I mean, it's manual, right? When you do this, you have to do it manually.
So that was part of the motivation why this was a good idea, because I was like, in implementing this, I messed it up like 4 times. So please let no one else mess this up ever.
But it's still unsafe.
Oh, it's hyper unsafe. Like
hyper unsafe.
Oh my god. Yeah. Is there anywhere where we're saying you should not be using this?
No, but the unsafe keyword is there.
Yeah, I guess.
What else do we have unsafe?
No, we have bold text. We have bold text to scare people off even more.
Okay, I honestly, and I get that I'm a person that wears glasses, but I cannot distinguish bold text from non-bold text. So unsafe is what tells me not to use something.
Fine.
Or be very careful when using it.
Anyway, this was about a year of going through the process.
Sweet.
Now we have it.
I see why you're excited about it.
Hey.
Right. Once call, once force. Can you do the button click and Ooh. So performs the same function as call once, except ignores poisoning. That's a weird turn of phrase. Unlike call once, if this once has been poisoned, i.e. a previous call to call once or call once force caused a panic. Oh, I see. It caused a panic. Calling call once force will still invoke the closure F and will not result in an immediate panic. If F panics, the once will remain in a poison state. If F does not panic, the once will no longer be in a poison state, and all future calls to call once or call once before will be no ops. The closure F is yielded a once state structure, which can be used to query the poison status of the once. This was such a tongue twister.
Yeah.
Is poisoning a common turn of phrase for something that causes a panic, or previous something caused a panic?
Yeah. So
Okay.
lock poisoning is the concept.
Okay.
So
Yeah.
imagine what was it again? I rarely like deal with this, but I believe the concept is, imagine you take out a lock, like on a thread, right?
Mhm.
A lock shared between like multiple things.
Yeah.
You take out a lock, so mutex or whatever. You take it, you hold it, then that thread, while you have that lock, panics.
Right.
What happens?
It has been poisoned, apparently. Yeah.
Well, essentially that's like a deadlock state.
Yeah.
So I believe like that should poison the lock. Every other.
Yeah. So it should be difficult or not possible for other items to get a lock on the same.
Yeah, they'll essentially get returned an error.
Right.
That's why mutex in standard lib, if you call lock on it, you need to .lock.unwrap commonly or handle the error.
Or handle the error.
Yeah, and this seems to be a way to recover from a poison.
It seems interesting if you're dealing with threads, I guess.
Yeah, it's on the once struct though, which is is it deprecated? It's definitely like pretty uncommon to use once. Oh, once in it is deprecated instead of using once. Yeah, since 1.0. There's also one cell, which is coming down, which is a different thing.
That will be a tongue twister for sure.
Yeah.
Okay, interesting. Perhaps perhaps the similar kind of functionality can be implemented in other lock style structures that would do a similar thing. I imagine like a lock having something like that.
Maybe. I'm not too familiar with poisoning, like I said. But what you're saying makes sense for sure.
Right. What's next?
Cool. Peekable, next if, eek, next if.
And those can be covered probably together.
So std_iter, peekable. You can call .peek on an iterator.
Yeah.
Oh yeah, you have an iterator. You can call .peekable on it. It essentially allows you to get a reference to the next item without consuming it. Because when you have an iterator and you call .next, you take the next item.
You take ownership literally of it.
But this like just gives you a reference too, and just holds it in memory for a duration of.
Seems nice.
Yeah, it's really useful when you're like writing parsers, because then you can be like, oh, is the next token this? If not, then you don't consume the token. But if yes, you take it.
I've seen a whole bunch of it because I'm doing a bunch of parser research work, so I've seen a bunch of peekables.
So, this is cool. So
next, this is super neat.
Yeah, you just say like, give me the next one if it's equal to this value. Perfect. Like this is how you write parsers.
Super.
Yeah. And this allows you to, I believe, skip the .consume step.
Amazing.
So this replaces, I think, let's just copy this. Let iter equals 0.5 So here you would do if iter.peek equals n0, and then you would do if iter.peek sum n0. Oh, was this it?
What are you trying to replicate?
Oh, I'm trying to like do the long form of this one.
Oh, okay.
And then you would here do iter dot next underscore, I believe it is. Yeah.
Right?
Yeah. And then here we can do print line iter dot next. But it should give us the number 1. Okay, because that's a sum, an option.
Yeah.
Yeah. So we indeed consumed 1 here, and then the next one is here. Right. But instead we can just be like iter next if. Yeah. So instead we can write, I believe, if let sum n 0 n iter dot next if eq
And 0.
and 0. Give me the n here. I just want to have n. Yeah. This should give us 1 again. Oh wait, no, actually nothing. Sorry, now it'll work.
Yeah.
There we go.
Nice.
Right. So this is the pattern rather than this. It allows us to replace the dot next call, which consumes 1. You just get it in like one go, which is much more constrained.
Seems good.
What was the other one? Next if.
Oh, this one gets you.
You can give the closure.
Closure is super as well. This is great.
Great. Cool.
Convenience methods.
Definitely.
Seek stream position up next. You're excited about this one?
Yeah,
too?
very. I've wanted this.
You have wanted this. Returns the current seek position from the start of the stream. This is equivalent to self.seek, seek from current 0. Cool. Oh, that's amazing. So you get to essentially just find out. Do you get a reference to the stream position? No, you get the stream position.
Yeah.
Okay, that's super cool. What were you gonna use it for?
So I remember wanting this back in 2018. I was implementing data REST protocols, and I built a crate called what was it called again? It's essentially random access storage. You could back it by memory, you could back it by file, you could back it by anything. It's like a collection of traits.
Right.
And we couldn't use seek because without stream position, seeking is an IO intensive method. Right. So default implementation of this will seek to the start and then seek all the way back and then report how many bytes it's like.
Oh, it has to read through the whole thing. Okay.
But if you overwrite this, then you can do an optimization where you just always keep the position in memory.
Right.
And you can always do seek to position, like stream position.
Right. So I guess now this implementation in source actually does that, keeps that in memory.
Yeah. So it comes with a default implementation, which we see here. Oh. What? What? Self, seek from current. But we can overwrite this, right? To not do the IO if we have enough bookkeeping, which oftentimes we can.
Nice.
So it's just very convenient.
I like that.
Yeah. Because seeking and just not knowing where in the stream you are is not useful. So yeah. Was the next one mine?
Yeah, sure. Array IntoIter.
Oh, I think we've covered this already, right?
I think so.
Yeah. Array IntoIter was highlight earlier. Panic any?
Oh, sure. Yeah, I've had to change a bunch of this to a bunch of my panics to match this.
Oh.
Yeah, you can't. So if I can.
Good luck.
Well, you're in Vim mode, yeah?
Yeah.
Great. Sounds good. So I think previously what you had to do, if you had any panics, you might have done blah.toString to panic. But now the common solution is to do this, and then you can just do that, and then pass it a string, or I guess if you had e to string or whatever error. I'm doing a terrible job of explaining, aren't I?
I'm not sure. Is this what it is?
Okay, so here, no, so what happens is I had a bunch of these in my code where it was panicking and I was getting like an error or whatever. I had an object that it just ran to string on. And one of the suggestions was to use panic any.
Okay.
Or just use like an inline formatting. But panic any is like a different way of writing this. So instead of having panic e dot to string, you can do panic any, which is now the method.
Fascinating.
E will not compile, I think.
Well, there is no e there.
Yeah.
Like, sorry, I'm just like trying to understand, because like what they're explaining here sounds like we can now send pretty much any struct, as long as it's like valid to send. But I don't understand like how that's like later reconstructed to a string. Right? Because if we send like a struct, like an empty struct, it implements any, it implements send, and it could be static. Yeah, it just doesn't need to borrow.
Yeah, I guess it's wrapped in a box. They wrap it in a box.
Yeah, but like how do you convert that back into a string? Right?
I don't know. Should we look at source?
Sure. Compiler implementation. Yeah. No. Like it's okay. It's okay.
This is not helpful.
Yeah. It's just I'm confused like what it's for and like what it does. Let's say here panic any. Each thread's panic can be reaped as the box any type, which contains either a stir or string for regular panic invocations. To panic with a value of any other type, panic any can be used. Oh, right. So if you want to just send any type of like error back out from a panicking thread to the capturing thread, this is what it's for.
Right.
So if you do thread spawn, it returns a result.
Right.
A thread result. And the error type can now be of any.
Interesting. You know what? I think so. The errors I've been getting was to use panic any for a string type in Rust Analyzer. I don't know where that error comes from, but I feel like I should not be suggested to do panic any when I'm working on a string.
Are you using Nightly?
I'm not using Nightly. I'm on 1.51.
But so that was this week.
This was this week, yeah.
Oh, okay.
Yeah.
Wow, okay.
So I think perhaps panic any should not be suggested for strings, which was my code, but this makes sense. So you use panic any to send back whatever value to the up to the thread.
I'm still a little bit unclear on this, but okay, interesting. Cool.
All right, should we move on?
Yes. Oh, I can. Yeah.
Oh, sorry.
No, it's okay. So we've covered these. Oh, perfect. That's one of mine. Yeah, so we've covered adder and adder of mute. Fill with. So 1.50, we got slice fill, where it can be like, imagine you initialize a vector with some value, and you can just call fill it with some other value. And I'll just like in a loop for every entry, I'll just fill it with that.
Right.
Fill with allows you to pass a closure.
Oh, nice.
That's called So in this case, there's a fun trick where you can pass default, and say we have a vec of ones and we want to zero it out. We can just do buff fill with, and then we have an empty vec.
But you can do it with a fill with and then give it like a set of values, right?
Not a set of values, a single value that's computed once.
Okay, cool.
But in this case, like the trick with default is very nice. Because Or is it called
null it
once?
out.
No, it's not compute at once. It's called for every value once.
Okay.
Yeah.
Cool. Nice.
Yeah. So because there's a different one which was like a different sort of API that we looked at, which had a X with underscore default,
Right.
but it's been deprecated because you can just pass default.
Right.
So yeah, this is also nice if you have like a vec of options. We'll just turn them all to none. Or if you refactor your code into something.
Yeah, I'll just basically use the default for whichever type you have in your
Exactly.
vec. Nice. Very nice. Very good.
Exactly. Yeah. So that's a nice little addition. Just good quality of life improvement, I guess.
There's a bunch of slice stuff.
Yeah. Do you want to do these?
Sure. So split inclusive mute. This returns an iterator over mutable subslices separated by elements that match the predicate. The matched element, I don't like it when they do it pred. I like predicate. The matched element is contained in the previous subslice as a terminator. I think I need to read through the code. That makes no sense to me.
There's also split inclusive, which may have a slightly easier.
Yeah, let's look at that. Split inclusive. Returns an iterator over subslices separated by elements that match predicate. The matched element is contained in the end of the previous subslice as a terminator. Okay, so... Okay. I see. If the last element of the slice match, that element will be considered the terminator of the preceding slice. That slice will be the last item returned by the iterator. Okay, so it's... Okay, I see. So it just helps you with a way to like do some number manipulation or slice manipulation, or if you're doing string splitting that you've made into a slice, I guess you can also do that.
I think like one case where this would have come like in handy for me. I've definitely had cases where I was like, I want to call slice split on either a carriage return /r or \r/n or /n.
Right.
But then I wouldn't know which one I terminated on.
Right. So you kind of want a way to figure out where you've been.
Yeah, like this will include the termination character in the slice that you get back. So you can look at it. And then you can be like, oh, I need to read one more.
Yeah, but it's also useful like if you genuinely like if you're doing some parsing logic and you want that character as part of it.
Oh yeah, totally.
So always like you have to like tweak the thing to get the right thing.
So this is the inclusive counterpart to the split family of methods, which also exists on Slice.
Super sweet. And I guess inclusive mute just gives you the same thing but mutable.
Yep.
Okay, that makes more sense now.
Cool.
Announce. What's next? Do you want to talk about the strip suffix and prefix?
Yes. Split inclusive.
On
stir.
On stir. Oh, perfect. Yeah, like for string manipulation. I think.
Is that the same as you just?
Yeah.
Yeah, it seems like it. Yeah, there we go.
Yeah.
Cool.
That's useful.
Yes. All right. Strip prefix. Zo. Oh, that was very German, wasn't it?
It was, yeah.
This is strip prefix suffix split end starts with. Yeah. So it is a nice little one. Oh, okay. Returns the subslice with the prefix removed. A. If the slice starts with prefix, return the subslice after the prefix, wrapped in sum. Returns the subslice. If prefix is empty, simply returns the original slice. If the slice does not start with prefix, return none. All right, so do we have two return types? No,
just option of NT.
If the slice starts with prefix, return the subslice after the prefix. Okay, so we remove it, wrapped in sum. If prefix is empty, so we don't specify prefix, we return the original slice. Okay, so that's an interesting one.
Do you return it as part of sum?
Yeah,
Okay.
because no prefix has been specified.
Right.
right? I was just confused by this case. I was like, wait, there's 3 cases? I would expect 2.
Yeah, because it's an option, right? But like you return the original slice, but you return some of the original, like you, as an option of the original slice, right?
Yes.
Okay.
Yeah. It's just a case like they're covering like what if the prefix that you're passing in is empty.
Yeah.
Right. Okay. If it doesn't start with prefix, return none. All right, that makes sense.
Cool.
Yeah. Again, this seems like a nice little quality of life. Suffix is the same, but like for the end.
Yeah.
This just seems like a nice quality of life improvement for if you like doing quick parsing stuff.
Super useful, yeah.
I wonder if Matplotlib did this one. Can we find the RFC anywhere? Anyone? No? Okay.
Is there a good blame on that?
Yeah, no. Unfortunate. Because I'm pretty sure he's done a couple of these. Yeah. I know Ralph did these, but I want to, yeah. Anyway. Blah, blah, blah.
Right. Sync one state.
Oh, we already covered that.
One state?
Yeah,
yeah.
Stuff.
I guess it's the same.
Yeah, I didn't get to click control.
Okay. Wake. You probably want to talk about wake because you've done a bunch of wake work.
Yeah, I've implemented it. Well, yeah.
Did you do this whole wake thing?
Well, I've done a good chunk of it.
Oh, okay, yeah. Then you should probably talk about it.
So both constructed it, but I wrote the docs for it and helped stabilize it over the last 2 years, 1 year.
Oh, nice.
1 year, yeah. So
and Boats and Yosh original.
Yeah, well, mostly Boats design, but
okay.
you know. So what's good to know about Wake? This is related to async Rust. When you're implementing your own futures, when you're digging into building your own runtimes, something I've had to do in the past. There's a bit of a layering here. So the whole task submodule currently is just low-level plumbing for these kinds of things. I won't cover the exact stuff, but sort of the ordering in this is raw Waker vtable is a completely unsafe struct with just raw pointers.
Right.
That is then wrapped by a raw Waker.
Right.
Now this is sort of the intermediate layer. So the raw Waker, which is wrapped by a Waker, which is wrapped by a context.
Okay.
Right? So these 4,
kind
they're
of
layered.
Layered on top of one another.
Yes.
Okay.
And then poll also comes in as a thing that some of these things reason about, specifically Waker. There's a wake method, which is past the poll from raw is wake here. Wake is there.
Let's just take self.
I'm just wrong here. Nah, it's fine.
So what about the trait?
Right. So just clarify. Previously, in order to construct a Waker, you had to construct a raw Waker with a raw Waker vtable. Super unsafe, right? Here we see just pointers, raw pointers.
Okay.
Right?
Okay.
Rust does not want to be dealing in raw pointers. So what we did instead of constructing this manually, you can now safely, rather than use a raw Waker, you can use the wake trait.
Okay.
To create a Waker.
Okay.
So Waker is essentially a callback that you can call to say hey, we're ready. So we can now safely implement things that used to be unsafe.
Amazing.
Which is kind of cool. So in this example, what we're showing is how to create a block on function. A block on function is it parks the current thread as you wait on a future to complete. So future will run to completion, or an async function. And here we essentially say block on, async function, do a bunch of async stuff within here. And then once this finishes, it returns the value out of this again. Here we don't do anything async. We just say print line hello from inside this future. But this is the full implementation with 0 unsafe within.
Amazing.
Yeah.
It's very easy to read through. When I read through this code, I sort of know what's going on. It's very, very nice. Good job to both of you. Good job to both.
Mostly boats again.
Yeah. Good job to boats. It's very good design.
Completion. Yeah.
Very good design.
Yeah. So just for reference, the way this works is you import wake, you define your struct, then you implement wake for your struct. And within it, you just say when this callback is called, when the Waker is called, what do we do? And here we say we unpark the current thread. So we remove it from sleep.
Mm.
And here we have like a little bit of logic, which is like, if the future is ready, then we return. If the future is pending, then we park.
Mm.
And then it calls a callback, unpark, continue again.
Mm.
It's just a little bit of stuff. But yeah, it's pretty straightforward. Yep.
Yeah,
little bit of safety.
seems really good. And it's nice that you don't have to do it from like an unsafe block anymore. So
Yes. We can probably like rewrite some utilities to make use of this
Amazing.
in the system. Mm-hmm.
Amazing. Right, so we're at the end of this. There's some other changes in Rust 1.51 release. Check out what changed in Rust, Cargo, and Clippy.
Rust, Cargo, and Clippy.
Oh, can you zoom in?
Oh, yeah, for sure.
I cannot see. Oh, okay. That's better.
So...
right.
Oh, yeah, we'll cover this.
We covered the resolver stuff as well, and
yes.
Rustdoc. You have your GitHub in dark mode. I don't like the dark mode in GitHub. I find it very difficult to read.
So I changed it from dark mode. There's a third mode now.
Oh, well.
Dusk mode.
This is the dusk mode?
I believe so.
Okay, I still find it a bit difficult for readability. I think the contrast is not... I'm just rambling. I'm sorry.
So there's a little Rustdoc update.
Oh, yeah.
If you implement Deref, the methods within are now also shown.
Oh, okay. Oh, that's actually super useful when
Yeah.
you're reading other people's docs.
Exactly. So that should mean if we look at string.
Yes. Yeah.
Hey.
Jinx.
Methods from Deref targets there.
Oh, good.
So now we can just look at string and be like, which methods do you have?
It's quite a few. Probably string was an ambitious example to look at.
Yeah, it was good. It's good. It makes it to be like, as bytes, does that exist on string? And it's like, yeah,
nice.
It does.
Cool.
Oh my God.
That's a nice little change to Rustdocs.
I agree.
Default theme flag, which says the default theme to use for documentation. For your specific documentation?
Yeah, you can build docs locally, cargo doc.
Oh, I see. I thought like different people can now choose different default theme for their docs, and I feel like that would just be madness. You go to one crate is dark, the other crate's bright light.
I think it's useful to separate between Rustdoc and docs.rs.
I meant docs.rs. I'm sorry.
Yeah. Okay.
Yeah. This is Rustdoc or docs.rs?
Rustdoc.
This is doc.
Yeah. No. It's good. Like docs.rs is a hosted version of Rustdoc output.
Yeah.
But yeah.
Cool.
Non-path primitives such as slice, associated items include generic parameters. So it seems you can like do more links. Cool. Never : eq. Fix introdoc links for associated items. String : from. Okay. Generic parameters in introdoc links. Oh, allow links like vect.
Okay.
Cool. Okay.
In miscellaneous they have, you can now pass include ignored to tests. So cargo test dash include ignored to include testing tests mark ignore. Okay. I guess to double check that works or not. Some compatibility notes. WASM platforms no longer use the WASM bindgen API. Oh, and instead use the WASM 32 API. Oh, hold on. Is WASM bindgen API deprecated or something? Or just WASI uses the WASM 32?
I think what's happening here...
Let's look at the...
Click.
Okay.
Yeah. So I think what's happening here is Rust sort of started doing WebAssembly before WebAssembly was fully stabilized, right?
Yeah.
Specifically, like WASI was up in the air. So I'm suspecting the WASM bindgen as a tool made some decisions, like these seemed likely where we'll end up,
Right.
before it was stabilized on the specification level.
Right.
And now they've essentially, it's become what they expected it was, so they just made the switch.
Right.
With minor changes, really.
Right. Okay.
But that's okay because, like WebAssembly, WASI is like not a tier 1 target,
Right.
and you want to follow the spec.
Right.
So if you're just sort of doing a thing to make stuff work and you remove hacks, that's viable.
Right.
Because that's just tracking the platform you're targeting. It's not considered a breaking change.
Okay.
I think that's what this is.
Okay.
So I feel like I'm talking quite a bit.
It's okay. I can do the next thing. Rust C no longer promotes division, modulo, and indexing operation to const that could fail. Let's click. I want to see the code example, I think. For division, will still be prompted if y is a non-zero integer literal. However, 1 divided by 1 plus 1 will not be promoted anymore. Okay.
Just seems like a stability thing.
Yeah, it seems like it. That's cool. The minimum version of glibc for the following platforms has been bumped to version 2.31 for the distributed artifacts. Is GNU Linux part of it? Yes. Yeah, yes it is. Interesting.
Well, I don't see any common ones though. Spark 64 unknown Linux GNU. I don't think we're targeting, or I'm never targeting that.
This one may be a little bit more common, but still it's like X32. It's not just GNU.
I feel like this is hobbyist grade change notes.
But 231 is quite high, I think.
I don't know.
Anyways, internal only, there is a change to consistently avoid constructing optimized MIR when not doing codegen. Mir, I don't know what that is.
Mid-level intermediate representation.
Oh, okay. But I guess this is internal only.
Yeah.
The optimized mir for closures is being encoded unconditionally while being unnecessary for cargo check. Okay. This turns out to be especially costly with mir inlining enabled since it triggers computation of optimized mir for all calls that are being examined for inlining purposes. So it seems like an optimization thing and makes cargo check faster.
Hey, always welcome.
Yeah.
All right.
Especially welcome for Last Analyzer.
Yes.
When you're on an older computer, that takes a little bit of time, a little bit of pats.
All right. Do you mind if I just blast through these?
Go for it.
All right.
Go for it.
macOS targets now default to unpack debug info. Oh. The default to it.
Hold on. Oh.
Yeah. So just upgrade to Rust 151.
And yeah.
It's now the default.
Amazing. Great for debugging.
Hey, the authors field is no longer included in Cargo Toml for new projects. Yay. Substack was complaining about this.
Oh, really?
On Twitter, yeah.
Oh, I didn't know they were complaining about it.
Because the authors field will scan your Git username and email and sneak it in to the Cargo Toml field, which is leaking. It's essentially leaking like confidential information, potentially compromising information.
Right.
Like you shouldn't like disclose user details unless a user
like specifically. Yeah. Cool.
I get why it could be like you just don't give it a thought, but the critique of it is like reasonable.
That's fair.
Yeah, I don't think like James's critique like prompted the change, but it's good that's being made. Yeah, at worst it could like out someone who isn't, like leak their real name or something.
Yeah.
Yeah, not good. Cargo update may now work with the -- offline flag. Amazing.
Super sweet.
Yeah, so Cargo update just bumps your versions, and if you have a version locally stored in your cache that's higher than that your project's using, it will just grab it from cache. You don't round trip over the network.
Sweet.
This was really good when planes were still a thing and you want to do some plane hacking.
What's a plane?
I don't remember.
What's plane hacking?
So fixed, nightly only, fixed topic.
Hey, is plane hacking when you just really don't want any of the spicy broth?
Okay, where's that mute switch?
I think I'm tired.
Yeah.
Nightly only. Go on.
Nightly only. Cargo 153. Oh, wait, hold on. Oh, hey. Okay, so in 153, they're switching over. We're looking at the wrong thing. That's fine.
Oh, yeah, I guess they...
Cargo 151. Split debug info profile option. We've seen that add a path field to cargo metadata. For the pack dependencies list to show the new path dependencies. I'm too tired to parse this.
I can read the next.
The new feature resolver we've covered. Cargo install -- locked. It emits a warning if cargo lock is not found. Seems useful. Unknown or ambiguous package IDs passed on the command line that displays suggestions for the correct package ID. Good. This is mostly like dash or underscore.
Right. Slightly optimized cargo vendor. I can do the fixed ones.
Do you know what cargo vendor is?
No, I don't know. What is it?
I believe it's when you like want to get when you want to vendor dependencies, like a Git subtree.
Okay.
Rather than using cargo itself.
Interesting.
Yeah.
Interesting. Okay, so fixed a bunch of stuff. Fixed environment variables and config settings emitted by a build script that are set for cargo test and cargo run when the build script runs multiple times during the same build session. Fixed a panic with cargo doc and the new feature resolver. Fixed a bug in cargo's cyclic dependency graph detection that causes stack overflow. Seems useful. Fixed build script links environment variable with a dep underscore not showing up for testing and packaging. There's some fixed features for the resolver 2. Fixed to use HTTP proxy in git config. Some fixes to the feature flag and package and feat for version 1 resolver for non-members. There's a panic in cargo doc that was fixed. Again, there's a few panics in cargo doc that were fixed in this release. Fixed cargo install from exiting with success if one of several packages did not install successfully. That seems useful.
Okay.
And another fixed panic with doc collision orphan. It seems like lots of panics in cargo doc.
Yep. I say we skip nightly.
And if you're on nightly, you can read this up here.
Yeah.
Cool. This was a fun release review.
Yeah. So we didn't cover like the biggest one really, which is the Const generic stuff. But yeah.
There's a video for that. If you wanna see us talk about it and do examples and stuff.
Yes. All right. So I think that's it.
Yeah. Good to see y'all.
Like, subscribe.
Oh my god.
Talk to us on Twitter.
He's
or
like
not.
this all the time. This is not just for the video, just so all of you know.
Maybe. All right.
Bye.